You've been following this object for some time now. Since it first appeared on July 1st, 2025, it has carried a quiet sense of unease. Its origin does not match anything familiar. Its path does not belong to the natural patterns we expect. And ever since its arrival, it has been under continuous observation, tracked by the most powerful telescopes on Earth and beyond. But the deeper question has slowly shifted. It is no longer just about what this object is. The more pressing question now is what it is doing. Because as of March 2026, 3I Atlas is positioned at the very edge of Jupiter's gravitational domain, and a small number of experienced researchers examining its trajectory, its chemical signatures, its jet activity, and the vast amounts of water it releases, are beginning to consider a possibility that has not yet entered mainstream discussion. Not that it is simply passing through, but that it may be slowing down. To understand why this matters, we need to step back for a moment and look at Jupiter itself. Jupiter is not just the largest planet in our solar system. It dominates it. In fact, the combined mass of every other planet still does not equal Jupiter's mass. It acts as a gravitational anchor, shaping the motion of objects across vast distances. Scientists define a region around Jupiter known as its Hill sphere. This is the zone where Jupiter's gravity becomes stronger than the Sun's influence on nearby objects. That boundary extends to roughly 33 million miles from the planet. And right now, 3I Atlas is sitting almost exactly at that threshold. This is where things become particularly interesting. When a natural comet enters Jupiter's gravitational influence, the outcome is usually straightforward. The equations are well understood. Orbital mechanics takes over, and scientists can predict, with remarkable precision, how Jupiter will alter the object's path. This predictability has been refined over centuries of observation. But 3I Atlas has not followed that pattern. Not at any point since it was first detected. And if it continues to behave differently, even here, under the dominant gravity of Jupiter, then we are no longer dealing with a familiar scenario. We are stepping into something far less certain. To see why, it helps to consider how objects typically enter a solar system like ours. The planets orbit the Sun in a relatively flat plane, almost like a disk. Imagine coins spinning across a tabletop, each one following roughly the same level surface. Now, if a random object drifts in from deep interstellar space, it would not be expected to align with that plane. It could arrive from almost any angle, often steep, often chaotic. There is no reason for it to match the structure of a system it has never encountered before. And yet, 3I Atlas did. Its trajectory is tilted by only 5 degrees relative to that planetary plane. 5 degrees is an extremely small deviation on a cosmic scale, placing it in near alignment with the orbits of every major planet in our system. The probability of such an alignment occurring by chance is estimated at around 0.2%. And that is only part of the picture. As it moved inward, the object passed relatively close to 3 major bodies. It approached Mars at a distance of roughly 29 million miles in early October 2025. It then reached its closest point to the Sun on October 29th of the same year. And now, it has arrived at Jupiter. When these events are considered together, the alignment, the sequence of planetary encounters, the timing, the likelihood drops even further. Estimates place it at roughly 0.005%, or about 1 in 20,000. There is also a detail that is easy to overlook, but difficult to ignore once noticed. At the exact moment when 3I Atlas passed closest to the Sun, the point where its activity would have been most intense, Earth was positioned on the opposite side of the Sun. From our perspective, it was completely unobservable. Whether that is coincidence or not remains an open question. But it does shape how we interpret what we are seeing now. And this brings us to one of the most significant observations so far. The water, shortly after perihelion, the Solar and Heliospheric Observatory, known as SOHO, detected an enormous cloud of hydrogen surrounding the object. This is important, because hydrogen in this context is a direct indicator of water being broken apart by solar radiation. From these measurements, scientists estimated that over the course of just 1 month, 3I Atlas released approximately 13.5 million metric tons of water, all within roughly 30 days. Water itself is not unusual in comets, but the scale here is striking. And more importantly, in space, water is never just water. In the context of space travel, water carries a very different meaning. If you pass an electrical current through water, it separates into hydrogen and oxygen, a process known as electrolysis. These two elements, when stored and used correctly, form one of the most efficient and powerful rocket propellants ever developed. Every major space program on Earth has relied on this combination. Even the space shuttle's main engines operated using liquid hydrogen and liquid oxygen. So, what we are looking at here is not just an icy object drifting through space, but something that appears to carry a vast, continuously renewable source of fuel, the exact resource a propulsion system would need to slow down, adjust its trajectory, and potentially remain within a new star system. In January 2026, Avi Loeb outlined a concept that builds directly on this idea. He described it as interstellar hitchhiking. The reasoning begins with a simple constraint. For any civilization bound to a planet with significant gravity, like Earth, launching a spacecraft capable of traveling between stars requires an extraordinary amount of energy. The fuel requirements alone quickly become prohibitive. But there is another possibility. Instead of building a vehicle to cross interstellar distances, you could make use of objects that are already doing so. Interstellar bodies like 3I Atlas are naturally ejected from their home systems. They drift through the galaxy for billions of years, moving from one stellar neighborhood to another without any energy cost to a passenger. In that sense, they represent a form of natural transport. Loeb's proposal suggests that an advanced civilization might attach a compact technological payload to such an object. The object itself provides the journey, and once it enters a new system, that payload could use locally available resources, such as the object's own water, processed through electrolysis, to make controlled adjustments, to maneuver, and to explore its new environment. And this is where another observation becomes difficult to ignore. Images captured by the Hubble Space Telescope revealed 3 distinct jets emerging from the nucleus of 3I Atlas. What stands out is not just their presence, but their arrangement. They are spaced at roughly 120 degrees from one another, forming a near-perfect triangular symmetry. Natural comets do produce jets, but they do so irregularly. Gas and dust escape from wherever sunlight happens to heat the surface, leading to uneven, unpredictable patterns. Symmetry of this kind is not what we typically observe. In natural comets, activity depends entirely on chance. Ice sublimates wherever it happens to be exposed, wherever sunlight reaches the surface. The result is always irregular, always uneven, and never truly symmetrical. So when 3 jets appear, spaced almost exactly 120 degrees apart, it naturally raises questions. In his analysis, Loeb pointed out that this configuration closely resembles a controlled thruster system. 3 equally spaced outputs would allow balanced force in multiple directions, enabling precise adjustments in orientation and movement. It is the same underlying principle used in spacecraft attitude control systems developed here on Earth. And the behavior of these jets adds another layer to the puzzle. Observations from the Hubble Space Telescope on November 30th, 2025, showed that the entire jet structure was not fixed. Instead, it exhibited a steady, repeating motion, rotating around the object's axis approximately once every 7.2 hours. This kind of regular, periodic motion is consistent with controlled rotation, what engineers would describe as spin stabilization, a method often used to maintain stability during flight. But the anomalies do not end with motion. They extend into composition. Recent findings published in March 2026, based on data from the James Webb Space Telescope, revealed that the water within 3I Atlas contains unusually high levels of deuterium, a heavier form of hydrogen. In fact, the concentration is more than 10 times greater than what has been measured in any known comet. Its carbon isotope ratios also fall well outside the ranges observed in our solar system, in nearby interstellar clouds, or even in protoplanetary disks. Taken together, these chemical signatures suggest something profound. This object likely formed between 10 and 12 billion years ago, in a region of the early galaxy with conditions very different from those around our Sun. In other words, it is not just foreign, it is ancient, carrying a chemical history that does not match anything we have encountered before. And with that in mind, Jupiter takes on a new significance. In this context, Jupiter is not simply an obstacle along the object's path. It is a potential resource. Its largest moons, Europa, Ganymede, and Callisto, are believed to harbor vast subsurface oceans beneath their icy crusts. Europa alone may contain more than twice the volume of liquid water found in all of Earth's oceans combined. If an object like 3I Atlas were capable of utilizing water as a propellant source, then the Jovian system would represent something remarkable. A natural refueling environment on a planetary scale. And Jupiter itself, with its immense gravity, could serve another purpose. Not as a barrier, but as a tool. A way to slow down. A way to slow down and transition into a stable orbit without expending large amounts of fuel. This is not a new idea. Space agencies have used it for decades. It is known as a gravity assist, using the gravitational field of a planet to alter speed and direction without consuming onboard resources. It is one of the most efficient techniques in space navigation. When we apply it, we call it careful engineering. But when an interstellar object, roughly 12 meters across, follows a trajectory with odds of about 1 in 20,000 and arrives at precisely the right gravitational boundary, it naturally invites deeper scrutiny. There are also direct observations adding to this picture. The European Space Agency's JUICE mission, the Jupiter Icy Moons Explorer, currently en route to Jupiter with an expected arrival in 2031, captured images of 3I Atlas on November 6, 2025, from a distance of approximately 41 million miles. Those images revealed a bright surrounding coma, with long, filament-like structures of gas and dust extending outward. Data collected during that period is still being analyzed, with initial results expected around late March 2026. So, we are approaching a moment where the picture may become clearer. For now, we can only summarize what has been observed. An object releasing roughly 13.5 million metric tons of water within a single month. 3 jets arranged with near-perfect symmetry at 120 degrees. A trajectory with an extremely low probability of occurring by chance. A chemical composition that does not match any known material in our solar system. An estimated age between 10 and 12 billion years. And a critical phase near the Sun that occurred completely out of view from Earth. Each of these points is supported by published and peer-reviewed research. What remains unknown is how they should be interpreted. One possibility is that this is an unusually complex natural object, one that simply stretches the limits of what we thought comets could be. Another is that we are observing a rare alignment of coincidences, a moment where the galaxy behaves in ways we do not yet fully understand. And there is, at least in principle, a third possibility, that this object may have been shaped or used by something beyond natural processes. If that were the case, then its journey may not be random. It may have been traveling for billions of years with a purpose, arriving in a system where a massive planet and its water-rich moons offer both energy and resources. After its encounter with Jupiter, current projections suggest that 3I Atlas will continue outward, heading toward the direction of the Gemini constellation, eventually leaving our solar system and returning to interstellar space. But one idea from Loeb's work lingers. If interstellar hitchhiking is not unique, if it is something that other civilizations have already learned to use, then one day we may attempt something similar ourselves. And when we do, we may discover that we are not the first to place instruments on such objects. We might, in a sense, to be encountering traces of journeys that began long before our own. For now, observation continues. The James Webb Space Telescope remains focused on this object. The JUICE mission continues to gather data, and new measurements from its interaction with Jupiter are still being processed. We are witnessing an event unlike anything recorded in modern astronomy. And perhaps the most important question is still the simplest one. Are we looking at an extraordinary natural object, or something that challenges how we define what is natural at all?